All right, we want to continue our exploration of our statistics, and we're going to look at some different types of graphs. These graphs have different construction methodologies, and because of that, we'll display data differently. And so, what we want to look at are going to be stem and leaf plots, dot plots, um, Pareto charts, and scatter plots and time series charts. And each of these are certain ways of gathering data. Stem and leaf plots and dot plots really grew out of people that wanted to gather data while they were observing something. And so they have a very observational technique. With the advent of electronic means of calculating data or gathering data, they're not as used as often, but you'll see that if you're observing something, stem and leaf and dot plots, you can really quickly get a graph just by recording your observations. And so a stem and leaf plot takes the digits of the number and turns them into something very similar to a histogram. But instead of having a set bin width, the bin widths are determined by the power of 10. So what we do is we take the first digit and we make that a category. We take the second digit and make it a category, or I'm sorry, the first digit category and the first digit category. So we have 20s, 30s, and 40s. So we want to keep track of the 20s, 30s, and 40s. And then we take the second digit and we use that to keep a count. Now, what's nice about this is in a histogram, we lose information about the original data. When I have put a value into a class, when I visualize the histogram, I have no clue what the original piece of data value was. But here, in a stem and leaf plot, I can look at the 2 and I can say, okay, 2 in the first piece of data is 21, and 2 in the 6 is 26. So you have a value for all the pieces of data that you have put into the different what would be classes. So here are 50 cell phone messages per user, and for 50 users. And so there's a lot of information here. We'd want to construct a stem and leaf plot. And if we look at this data, we have numbers down to the 20s and numbers all the way up to the 140s. So you would build the highest number of 17 and the largest number of 148. So you would have an entry from 17 to 14. And so this would be for the 10s, the 20s, the 30s, the 40s, the 50s, the 60s, the 70s, the 80s, the 90s, the hundreds, the 110s, the 120s, the 130s, and the 140s. And you take each piece of data and you put in the second digit. So we have 17, 18, 20, 23, and so on. And from this you can see a shape of what looks like a histogram. And we can see that the bulk of the data is between 20 and 50, right? Almost everything is right here. And so stem and leaf plots are a really nice way to collect data. And if you're actually observing people, you could write down these numbers and really create the stem and leaf plot. Maybe not with them being in order, but by as the numbers come through. So it's a fairly quick way to get something very similar to a histogram. Now, we could look at the previous data and we could decide to get more rows out of it. We could divide by 5s. And so we could do this by being the first one from 1, 0 to 4, from 10 to 14, and from 15 to 19. And so by doubling these, we get a slightly different view of the data. This would be similar to in a histogram increasing the number of classes that we use. And in this case, we can see that yes, 50% of the data is here, but it's definitely highly peaked around the upper 20s. And so we get a little more detail of what's happening. Another type of plot is a dot plot, where you write a number line with all the values you want within your range, and then every time you get a piece of data, you put a dot down. Now this doesn't separate it into individual classes, and so that we can get gappy. And this would be an example of if you had too many classes, you get gaps. But it also quickly puts information together. So you have a number line, you have all your values in, and you put a dot down every time you get something that falls into there. And so again, looking at the same number of text messages, and we go to construct a dot plot. So every time you see a number, you put a dot down above the number. And this creates the same pattern. In general, we can still see most of our data is here between 20 and 30 with a high concentration right in here. I'm sorry, 20, I said 30, but I pointed to 80. My apologies. Between 20 and 80, with most of it within this between 20 and 50. So we can get a similar information, but the visual is different. Another way of organizing data is within pie charts. Now, pie charts are set so that everything is proportional. The whole pie is 100%, and we sweep out angles equal to the percentage of data or the frequency, the relative frequency of the data. What a pie chart can do is it doesn't suggest an order for the data in one way or another, and it's really, really good for qualitative data. So here we have a list of degrees. We have the associate's, bachelor's degree, master's degree, and doctoral degree listed in numbers of 1,000. And so if we want to work our way through the angle, what you want to do is take the relative frequency and multiply it by 360, and that'll tell you how far around the circle to go. So for example, there were, out of all of the bachelor's degrees, if I go back up here, oops, if we add up all of the degrees, get my calculator out. So 1,037 plus 2013 plus 834 plus 188, there were 4,072 degrees. So 1037 divided by 10, yep. Let me get my number right. 1037 plus 2013 plus 834 plus 188 is 4,072. And so 1037 divided by 4,072 is 2.54 or 0.2546. So we round it up. And so that gives the relative frequency here. And if we multiply this by 360, we get the angle. And so we could sit here with a protractor and draw out the angles. Excel does a great job of creating pie charts. They're the love of business people, because in a lot of businesses you might be dealing with classes of information or qualitative information. But what's really nice about the presentation of this information is how much it sweeps out visually tells you the value of the qualitative information that's inside of it. And inside of Excel, we get the ability to create a pie chart and the pie chart comes across. Now, again, starting in Module 3, we're going to start doing constructions in Excel. In fact, our first project to work on will be taking some data and creating histograms and pie charts and pie charts in Excel, so that we can get used to using technology to do this for us. A Pareto chart is also a way of doing qualitative data, and it's vertical bars. Now, there's something specific about Pareto charts. Because it's qualitative data, you sort everything in order from highest to lowest. And the height of the bar is determined by the frequency count of what you're looking at. So here, if we look at the leading cause of death in the United States, and we look at this information, we see heart disease is the highest number, followed by cancer, followed by chronic lower respiratory disease, followed by accidents, then chronic lower respiratory disease, and then strokes. And so if we put that into a Pareto chart and match the number of cases to the bar height, and then we put them in order. And so because you want to go from lowest to highest, the qualitative information then is ranked from the largest to the lowest. It's very important when making Pareto charts. In a lot of the technology, you have the ability to close the gap. But because this is qualitative information and it's not numerical, we want to make sure there is a gap, so it's not confused with a histogram, which is actually numerical information. And so that, remember, we subtracted the 5 and added the 5 to close the gap. Another thing we can do is if we have paired pieces of information, if we have data that comes in pairs, we can turn this into points. And so that's called a scatter plot. And scatter plots are a really, really good way of looking at relationships between two variables. In Chapter 9, we will look for a way of measuring how related things are with two variables. But to graph things with two variables, we'll use the scatter plot. So, and a very, very important piece of data was Fisher's iris data set. And Fisher and Tully did some of the very early work on tuning better tools for statistics coming out of the late 1800s into the 1900s. Fisher and Tully and Jeffries write a lot of the functions that we end up using. And if you go downstairs, I think there's a Lady Slippers poster in the Mount. So if you're ever in Gardner in the Mount downstairs, on the first floor near the botany department, someone had done some research on lady slippers, and the data set is very similar to Fisher's iris data. But what we look at is the length of the petal and the petal width. And so how long the petal is versus how wide it is. Right? And so the petal length and petal width. And so on the x-axis, we get the length, and on the y-axis, we get the width in millimeters. And what we can see is the data clusters with petals that are not that long. They do not get a width. But then there's a gap, and the length increases with the width. And we can get a relationship. There's kind of a line that shoots through the middle of these. And that line can tell us something about the relationship directly between or indirectly between the length and the width. And so as petal length increases, so as the length increases, the width tends to increase. And so there is a linear nature. As the one gets bigger, the other gets bigger. And like I said, in Chapter 9, we'll find a way of finding the lines that best describe the data and determining how close the data is. Is this going to be really close to the line, or is it very scattered? But creating the plot, you take the two things you measured, the width and the length for each flower. And what's important about a scatter plot is instead of just measuring one parameter or one statistic of the thing you're studying, you're measuring two. And those two things are connected as a pair. And because they're a pair, we can put them onto a graph as a dot. Another thing we can do is as time passes, data might change. And so that lets us create a thing called a time series plot. And so if we get a value at a certain time, we put a marker down at that value. And so here we have burglaries and robberies in the millions per year. And so we can use the years on the x-axis to describe the time advancing, and then we can look at burglaries my pronunciation is off tonight, sorry. Burglaries and robberies as being the height in the y-axis. And so if we put the paired data of bringing the horizontal axis being the years and the vertical axis being this says motor vehicle thefts, but let's get to the plot. So we have burglaries in millions. And so we look at the year and how much we have in millions. And we notice a trend that burglaries are declining. And so time series can let us see how a number is changing over time. Again, it uses paired data. The number for a given year, we have to line up. And so we think of this year value and the value that is matched for the year. And those are some extra types of graphs we can do. Their construction, I want you to play with in the homework. But that covers what we're going to do in Chapter 2. If you need anything, please email.